Let us look at proposition number 11 of book 10 of Euclid's Elements. The proposition says, if four magnitudes are proportional and the first is commensurable with the second, then the third also is commensurable with the fourth. But if the first is incommensurable with the second, then the third also is incommensurable with the fourth. It is pretty straightforward. We are given four magnitudes A, B, C, D such that A is to B is equal to C is to D. If A and B are commensurable, C and D are also commensurable. And if A and B are incommensurable, then C and D are also incommensurable. So let's take it one by one. The proof is pretty straightforward. So the first case is A and B are commensurable, which means A and B have a equivalent number is to number ratio. And we know A is to B is equal to C is to D. So therefore, we can say C is to D also has a number is to number ratio. And since C and D have a number is to number ratio, we can say C and D are commensurable. Okay, so that was the first part. Second part is, let A and B be incommensurable. That means A and B does not have a corresponding number is to number ratio. And we know A is to B is equal to C is to D. So which means C is to D does not have a corresponding number is to number ratio as well. And since C and D don't have a corresponding number is to number ratio, we can say C is incommensurable with D. So as you notice, the crux of this is that A is to B equal to C is to D. So whatever is the property of A and B, same will be the property of C and D as well. So that was proposition number 11 of book 10 of Euclid's Elements. Again, let me remind you, there is a link to a PDF book which describes all these propositions in detail. Please feel free to download it, refer to it, and if you think somebody else can also benefit from it, please do share. That's it for now.